Hi, this video we're going to learn how to use Solidworks to design part, assembly, then maybe some simulation, because I believe some of you all might need some of the simulation function. Okay, so this is the interface for Solidworks. So we starting by creating part. So you just choose new, then part. Okay, so let me try to draft. Maybe let's build some heatsink. Okay, so first you need to do a, a sketch. Okay, okay, sketch maybe. Okay, I will recommend you guys use a coordinate function, so it will be more precise, then easy for you all to do some modification in the future. So now I just draw 100 by 100, then yeah, it's done. Then I use a feature function to make it as a block. Okay, so I just put 100 also. Okay, now we have 100 by 100 mm cube. Okay, and so now I press spacebar. Okay, so I can choose like uh, which view I want uh, to to see, or I can choose which view. So I also can rotate them. Okay, yeah, I also can pan or move them around. Okay, so this kind of interface I won't go too detail. You will pick it up. You will pick it up when you use. Okay, so now I have a block of maybe aluminium. Yeah, we try aluminium. Okay, now what should we do with this? Maybe I make a slot, let's say a fin, to increase the surface area. So yeah, I want to extrude cut. Okay, I want to cut this side. So maybe I just yeah, I just cut some slot. Okay, then yeah, you see why I recommend why now you quite understand why I recommend coordinate method. So I can draw it more precise. Okay, now I do like 5 mm. Okay, so the thickness, it will be 5 from this side. So just now is 2. Let's say I want the gap will be 3, or maybe I put it 5. Okay, so for this one, then I can use linear. Okay, I just choose this one, or this linear. So I don't need to draw so many. Okay, maybe how many I need, and just increase. Okay, so what's the purpose over here is the purpose for this one is I just want to increase the surface area for for cooling. Okay, now we try to design a heatsink. Okay, yeah, something like this. It is not a really good one, but yeah. Okay, done. Okay, done. And how much should we cut? 100 also. Okay, then done. Okay, you have some heatsink over there with a gap. So it's not a really good heatsink, but but this one is just for demonstrate. Okay, can. Okay, you have heatsink over there. Okay, what I need to another one is maybe I just, let's say I using peltier for cooling. Okay, so I just draw a peltier. So I create another one, new part. So for example, I use a 127 2706 Peltier. So this one is based on my experience. Okay, I have used this Peltier before, so the size will be 40 by 40 mm, and then the thickness will be something like 4 mm. Okay, so it's depend on what you're using. Okay, some of it you can download online. Okay, so now I have those two parts, Peltier and heatsink. Okay, then we can do the assembly. So you will need some time for you all to learn, like how to design a part. So just now I already designed two parts, so I get used to this kind of environment, the GUI, everything. So for y'all, maybe y'all need some time to get used of those kind of function. Okay, now I can use assembly. So actually they asked me to choose, I think, which part. Yeah, I don't want to choose from here. Okay, I know, I see what happening over here. So I cancel first. Okay, so actually it's recommended you save this. Okay, okay, I just create a folder testing. This one will be our Peltier. I just put 212706. Okay, this is our Peltier. Then another one is this one will be our heatsink. This one will be our heatsink. Okay, heatsink 01. I just save them. Okay, so if I save them, right, when you create a assembly, or you open a new assembly with those open part file, normally they will show you in the list. Yeah, this is what I mean. You see, they will have those list of the part for you to just put in your assembly. So now I can just click here. I can put my part in my assembly. Okay, so I need to put another one. Okay, so the next is how we going to assembly it. Okay, for this maybe we can just use a simple method. So for now I use a made. Okay, so this one will be my main part. This one will be my component. Okay, so I just made this surface. Okay, I made it with the heatsink. Okay, yeah, you click OK. So I will just move it in the middle. Okay, so it's done for simple assembly. Okay, so so yeah, that's our assembly. This one is a simple assembly. So for your project, you might be more complicated. Maybe you have like maybe 100 or maybe more than two part to combine together. So it is still the same method. Okay, so it's depend on your project. So for now, right, we have those assembly file. Now I can just show you the flow simulation. So this one is depend on your requirement or your application. So now I show you the simulation. So for this one, like I tell you before, this is our Peltier is a cooling module. So for this simulation, we're going to set the like condition. No, we cannot set the condition. So I need to set the situation first for the simulation. Okay, so you just go to wizard. Okay, yeah, they ask you to save the document, so you can just save it first. Okay, I just save it as testing. Okay, testing assembly file. Okay, I save it. Okay, then I run wizard. Okay, so this is a wizard. Okay, so you just go through the setting for the wizard. So I will go through with you for simple simulation. So this one will be under flow simulation. So you open the wizard. So they will ask you project name. You can put whatever name you like. Okay, so next they will ask you a unit SI or unit system. So normally I will use milligram and second. Okay, this one is up to you also. Okay, they will ask you like internal or external simulation, all those kind of stuff. So I just show you how it works, but it depend on your application. I cannot cover all of those simulation method. So for this case, maybe I just choose like heat solid, okay, or radiation. Then I can maybe set an environment temperature to be 25 degree. Okay, I don't need solar radiation, maybe it's just indoor. Okay, I put time dependent or how long I want to run this one. Maybe I just put it at 10 minutes 600 seconds. Okay, I don't bother about gravity, rotation, or free surface. Yeah, so they have so many configuration you can do, but it's like I say, it's still up to you all to configure. So for this one, maybe I just want to know the cooling effect for the heatsink. Okay, then maybe I just use air, right? Normal air. I just add it. Okay, then next. So maybe the material I just put it as aluminium, normal aluminium. Okay. So in no wall condition, yes. Next. Okay, this one is the temperature for the thermodynamic parameter. This one I think is the initial temperature. So we just set it 25. Then solid parameter also, yeah, the initial solid parameter, you just set it to 25 also. So I think that's all for simple simulation. So it depends on your situation, what kind of what kind of thing you need to set. So for this case, okay, one more thing I need to do. Yeah, I want to set the airflow so it will blow directly to the heatsink. So you see, I checking the heatsink orientation. So this one will be Y. So maybe I just put negative Y. Okay. Then the air will flow in toward the heatsink. Okay. Yeah. But anyway, you can change it. Okay. So you can change it in the setting by right click, I think right click this input data. Yeah, you still can change it. Okay, okay, no problem. So next what I need to do is I need to tell the simulation. Okay, I give a condition over here. This one will be thermal cooler. So this guy is thermal cooler. So this one will be the heat part. Okay, I cannot select the heat part. So first I need to make it, because I want to select the hot surface for the Peltier, but this guy is blocking. So now what I'm trying to do is make the heatsink transparent. Okay, I change it to transparent. So in this case, I can I can select the surface. Okay, this one will thermal. So this the hot surface will be on the heatsink side. Yes, this one I need to select this. Okay, so what's the Peltier? Yeah, maybe we just use, I don't know, maybe SP. Do they have one. Okay, maybe don't have. You can use just normal single stage. uh, yeah, I think I will use the CP model. Yeah, they have 12706. So maybe I just put 3 amp. Yeah, the current for the Peltier. Okay, okay, I think that's done. So now what we can do is we can run the simulation. So this one is depend on your computer. I won't recommend you to run from your laptop. Okay, it might overheat your laptop, all this kind of stuff. Okay, try to use desktop to run the simulation. Yeah, if those need some help, then maybe you can look for me. I will try to guide you all to for the simulation part. Okay, let's see how long this one will take. Hopefully it won't take so long. If it takes so long, then I might need to skip the video, or maybe I need to fast forward the video. Okay, normally they will use a lot of CPU processing. Okay, you can see over here it's almost 100%. I'm using old CPU, yes, with 8 core, then 3.4 gigahertz. It will take some time. Let's see. So it will take about 5 minutes. Okay, you can see the calculation time. So for those 5 minutes when it run, then maybe I can show yours more some of those function while we waiting for for the simulation or the calculation. Okay, so this is our calculation simulation. Okay, so yeah, maybe I just make this one. I just make it bigger. Which one? Yeah, this one. So yeah, so this is the part. So the next thing, what related to the part assembly? Have you know our assembly is built by using this part. So whatever you change to the part, okay, it will change automatically to your assembly part or your assembly. Okay, so whatever editing you do over here, now I cannot show because I use that part for assembly, so it will reflect to the assembly. So you need to be careful. So what I suggest you all to do, right, you just open a folder, then whatever project you're doing, just put everything in that folder, so you won't get messy, and then like you cannot find your part or missing part or this kind of thing. Okay, then another thing you need to be careful is the version of the Solidworks software. I think you can use the latest one, but you cannot use the latest or the latest file. You cannot open it on the old version, something like that. Okay, so you need to be careful of those or the version of the SolidWorks. Okay, one more minute. Maybe I will edit the video, or let's see. Let's try to check the temperature also. Wow. Yep. I need to do something with the temperature for my desktop. Yeah, so for now this is the one I have. Yeah, then one more bad news is it doesn't support on uh, Mac, Apple Macs computer. So SolidWorks you cannot run on Macs. So now what I'm doing is I'm remote desktop from Mac to Windows system. So now you can see the this video have been done with a remote desktop. Okay, 10 more seconds. Yeah, I think I won't skip the video. So yeah, just 5 minutes maybe. If not, you all just like maybe fast forward if you want. If you don't want to wait for 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 the calculation time. Yeah. Okay, now it's done. Okay, solve finish. So you can see the CPU also coming down. Yes, CPU also coming down. Okay, now we can open the which one. Okay, sorry, I cannot remember. I think it's supposed to be this guy. Is it this one? Is it the assembly? No. So it will the middle one. Yes, assembly. Okay, the icon will slightly different. So it will be this one. Okay. So now we have done with the calculation. So we can pull out the data, or we can see the result. So how to see that is that, yeah, from this result, right? Let's say I want to see the flow, uh, the the flow, yes, trajectory, yeah, something like that. So I can just do the setting. Let's say I want to see what we're going to see. Maybe I use line and arrow. Okay, this one maybe I just set to 1 mm. I don't want to see the pressure. Maybe I want to see the temperature. Okay, where the flow. So I just select everything. Okay, I just want to see everything. Okay, then yes, okay. Okay, then I can. Hmm. So where's my flow? Technical error. Okay, where's my flow? I try again. Okay, I just select all. Arrow maybe 1 mm, maybe 200. Line arrow temperature. Yeah, this one should be okay. Okay, I also not sure. Maybe some technical issue there. Okay, let me check the surface. We have done the. Okay, I want to see the temperature also. Solid, maybe over here. Everything, yes. Maybe I put the region. I put. Okay, maybe I put 20 for this one. So I need to double check what happened for the flow that one just now. Maybe I need to recalculate or something like that. No load. Okay, now I need to load the result. Now I know what happened. Yeah, you need to load the result. So the time will run at 600. Okay, so now I set the, yeah, now I can show. Okay, wow. The heatsink is very hot at 40 degree, but our Peltier is very cold. Yes, we have a minus 29 degree on this surface. Okay, so you can do this kind of simulation for your project. Okay, now I try to see the flow. uh, yeah, I think I set too much. Okay, yeah. So this is the air. Just now I tell y'all the air will come from y-axis. So it's blow directly to the heatsink. Yeah, so you can see our heatsink is not that good because it cannot cool down very well. Okay, the surface area is not maybe not enough. So all this kind of thing you can do in the Solidworks flow simulation. So for some of those who need, right, yeah, you can consider Solidworks for this kind of task. Okay, so I think that's all I will cover for this video. Okay. So any question? I'm not sure how about question. Maybe any question you can just ask me directly. I don't think I will read the comment. You can try with the comment. Hope you luck. Okay. Yeah. So yeah, that's all. I won't cover the solid cam for this video. So that one maybe I will cover on another video. So yeah, that's all. Thank you everyone and have fun. Bye.